Stated Clearly presents What is the evidence for evolution? The theory of biological evolution makes two very bold claims about living creatures. First, all living things on Earth are related. They evolved from a common ancestor. Second, the evolution of living things is powered by natural processes, things which can be studied and understood. But is there really any evidence that these two claims are true? Yes. There are so many observable facts from so many different fields of study that the only way we can even begin to talk about them is to group them into categories or lines of evidence. To keep things simple, here we'll focus on evolution's first claim that all living things on Earth are related. We cannot tackle the entire tree of life at once. After all, there's an estimated 8.7 million species alive today. So instead, we'll focus most of our attention on one fairly small but fascinating branch of the evolutionary tree, cetaceans. This branch includes whales, dolphins, and porpoises. Biologists tell us that all these creatures are closely related, and that the entire group evolved from an ancient four-legged land mammal. Instead of taking their word for it, let's look at the facts. We'll start by looking at a few from the field of comparative anatomy, the study of differences and similarities between living things. Whales live in water, and from a distance, they sort of look like giant fish. A close inspection of their anatomy, however, tells us a very different story. Whales, just like land mammals but unlike fish, have placentas and give live birth. They feed milk to their young. They are warm-blooded, which is extremely rare for a fish. And whales do not have gills. Instead, just like us, they breathe air with two fully developed lungs. Whales don't seem to have noses like mammals do. Instead, they breathe through blowholes coming out the tops of their heads. Some whales have two blowholes which almost look like nostrils. But dolphins and porpoises only have one. Surprisingly, if you look at their skulls, you find that the blowhole splits into two nasal passages inside the head. Could it be that the blowhole is actually a highly modified mammal nose? It looks that way, but we'll need more evidence to be sure. Many whales have hair, just like land mammals. In this photograph, you can actually see the whiskers of this baby gray whale as he rests his chin on mama's back. Strangely, whales have arm, wrist, hand, and finger bones inside their front flippers. Here's a photo of these bones, the same bones that bats, hippos, and people have in their front appendages. One bone, two bones, wrist, hand, and finger bones. Modern whales do not have back legs, but they do have a strange pair of bones where the hind legs should be. Here's a picture of these bones from a bowhead whale. They almost look like shriveled hip, thigh, and shin bones. This one even has a ball and socket joint between the hip and thigh bone, just like the ball and socket joint in your own hip. Is this resemblance a mere coincidence, or are these real leg bones? Perhaps leftovers from the whale's evolutionary history. Before we draw any bold conclusions, let's see if a completely separate line of evidence will confirm our suspicions. Embryology is the study of how creatures develop before being born or hatching from an egg. Here we see a dolphin and a human embryo side by side at similar stages of development. Notice that they both have what look like arm buds and leg buds. In humans, the leg buds grow to become legs. In whales, they grow for a while but then stop, effectively fading away as the rest of the whale continues to grow. These are all photographs of a common dolphin at different stages of growth. Notice that early on, we see two nostril grooves on the front of the face, just like you'd expect in a puppy or a human. As the dolphin continues to grow, the nostrils migrate to the top of the head and fuse together, becoming the dolphin's blowhole. So far, we have multiple facts from two independent lines of study, comparative anatomy and embryology, that are both telling us the same story. The ancestors of whales were once four-legged land creatures. Will the fossil record act as a third witness, confirming this idea? These are two species of extinct basilosaurid whales. These animals are known for multiple well-preserved skeletons, and they appear to have lived side by side, roughly 34 to 40 million years ago. In this photograph, we're looking down at the top of a basilosaurid skull. This is not a model or a cast, these are the actual bones which were pulled from the ground. Notice that the nasal opening is not on the top of the head like those of modern whales, and not at the end of the snout like those of land mammals. Instead, it's right in the middle. This is an intermediate species, exactly what evolution tells us we should find. At the back end of a basilosaurid's body, there are small, yet fully developed hips, legs, ankle, feet, and toe bones. These legs are far too small for walking on land, but they may have been useful while mating, or for scratching away parasites and itchy skin. Evolutionary theory tells us that the further we go back in time, the harder it should be to distinguish whales from normal land mammals. Meet Myocetus. The hip bones of Myocetus seem sturdy enough to walk on land, but this animal is considered to be a whale for many reasons. Their skeletons have all been found among fossils of sea creatures, which tells us they lived in the ocean. Their short legs, combined with long, flat fingers and toes, suggest they were strong swimmers with webbed hands and feet. Here we see the bottom side of a Myocetus jaw and skull. Her teeth match those of the basilosaurid whales we saw earlier, and the unique structures of her middle ear bones match those of basilosaurid whales and modern whales. Myocetus appears to be a walking whale. Scientists have found the fossils of many ancient whale-like mammals and continue to find more. Together, these fossils blur the line between four-legged land mammals and fully aquatic modern whales, solidifying the idea that whales indeed evolved from land creatures. Now let's look at a fourth line of evidence, DNA. DNA molecules contain chemical codes which act like recipes for living things. Without ever looking at bones, embryos, or anatomy, researchers can compare the DNA code of different living creatures to find out who is most closely related to who. Whale DNA has been compared to all kinds of other animals, fish, sea lions, you name it, and so far, the closest genetic match is to the pudgy, water-loving hippopotamus. This does not mean that whales evolved from hippos, but if this genetic finding is correct, whales and hippos both evolved from a common ancestor that lived roughly 54 million years ago. At first, the link between whales and hippos surprised researchers because whales are mainly carnivores. They eat things like fish and small crustaceans. Hippos, on the other hand, are mostly vegetarian. A closer look, however, reveals that hippos and whales actually share many strange features, some of which may have come from their common ancestor. Ancient walking whales have specially shaped ankle bones found only in hippos and the close relatives of hippos. Just like whales, hippos are known to give birth and even nurse their young underwater. They both have multi-chambered stomachs, which is common for herbivores but is almost unheard of for meat-eating mammals. They are both missing a coat of fur, and here's a fun fact. Whales and hippos are among the only mammals on Earth that have internal testicles. So there you have it. 4 independent lines of evidence all tell us the exact same story. Whales evolved from 4-legged land mammals. But the history of whales is not the only evolutionary history that we've been able to work out. We know from fossils, DNA, embryology, and many other lines of evidence that bird wings are actually modified arms and claws. Birds evolved from dinosaur-like ancestors. We can also clearly see that bat wings evolved from 5-fingered hands, very similar to those of monkeys and shrews. We've found that humans share a fairly recent common ancestor with chimpanzees, that mammals evolved from reptile-like creatures, those reptile-like creatures evolved from amphibian-like creatures, those amphibian-like creatures evolved from fish-like creatures, and fish, if you go back far enough, share a common ancestor with segmented worms. So to sum things up, thousands of observable facts from completely independent fields of study have come together to tell us the exact same story. All living things on Earth are related.